Hello and welcome to R&D Mathematics. Today we are going to talk about remainder theorem. Remainder theorem. Now this would be straightforward from our last video. So let me first state the theorem. It says if a polynomial f of x, if a polynomial f of x is divided by x minus k, then the remainder is f of k. Simple as that. So if you divide your polynomial by x minus k, then the remainder is f of k. Now let's see an example and verify this first. Now let's say our f of x is, how about this? Let's say f of x 6x to the fourth minus x cubed minus 15x squared plus 2x minus 7. Let's say that is divided by x minus 2 and we would like to find the remainders. Now, if x minus 2 is a factor, the remainder must be 0. But if it is not, there will be another some number. Let's say, according to this theorem, the remainder is simply f of 2, right? So according to that theorem, that's 2, f of 2. Let's check it. Let's check whether this is true. So minus 15 times 2 squared minus 2 times 2 minus 7. So 16 times 2 into 2 into 2 into 2. So 2, 2, 4, 8, 16 minus 2 cube 8 minus 15 times 4, 60 minus 4 minus 7. 16 into 6, that's 96. So, okay. How do we add? If I were you, I would 96 and here actually plus 2 right here plus, so plus plus here plus, so 96 and 4, that will give me 100, right? 100 minus 60, that is 40. 40 minus 8, 32. 32 minus 7, 25. That is the remainder according to this theorem. Now let's check whether this is true. Let's check. How do we check? Well, let's actually divide this thing. Let's divide this thing and see whether that works. Now 6x to the 4, that is in standard form, so we don't have to worry about much rearranging. We don't have to worry about rearranging terms. So already in nice form. So x minus 2, you put it here. Let's say I need 6x cubed. So I get 6x to the fourth and minus, when I multiply this by this, I get 12x cubed. Subtract, I get here minus x cubed minus minus 12, so 11, because it's plus 12. 11x cubed minus 15x squared plus 2x minus 7. When I need to plus 11 now, so 11x plus 11x squared, so 11x cubed now minus 22x squared. When I subtract, okay, minus minus plus, so I have 7x squared plus 2x minus 7, so I need plus 7x, so it will make me 7x squared minus 14x. When I subtract that, I get minus minus, so 16x minus 7. So finally I need plus 16, we are almost done, so 16x minus 32. When I subtract it, x is gone, 7 minus minus 32, so 7 plus minus 7 plus 32, that means 32 minus 10, which is 25, and we are done. See, that is correct. So you can avoid, if you just need to find the remainder, you can use this remainder theorem without actually using the longer division. Now let's see why this works. Let's see actually why. A theorem must have a proof. So this is the proof. Now in our last video we learned, for example, let's take this f of x. After we divide this whole division, and it can be explained like this. 6x to the fourth minus x cubed minus 15x squared plus 2x minus 7, that is the dividend, divide by the divisor x minus 2 equal to the quotient plus, so the quotient is 6x cubed plus 11x squared plus 7x plus 16. Let me erase these lines to make it look nice. So plus 16, this is the quotient. See, let me label them. This is the dividend. I explained this in my last video. This is the divisor. And this is the quotient. We are not done yet. Quotient. Plus, it must be remainder, which is 25 over divisor x minus 2. I think you can remember we did this thing last video. So this is the remainder and this is again the divisor. This is how we nicely put our answer in the final form. Now let's see why this guy is true. Let me go to the next page. So in general, when I divide by f of x, let's say I divide by x minus k, and the quotient, let's say quotient q of x, quotient plus remainder, let me put r, over x minus k. Now let me go to the previous page. So what I did was actually let me actually take this part and take it. So this one, the general version of this one, see, instead of our example, in general f of x minus divide by x minus k equal to the quotient, which is q of x, equals plus remainder, which is r, divided by again divisor, which is x minus k. So this is the blue color one, is the general form. Now if I multiply the whole thing by x minus k, what will happen is, left hand side, see, I can multiply whatever the number as long as I do it to both sides of my equation. So f of x is going to be, let me actually multiply. So this is your plus r over x minus k. So when I multiply the whole thing by x minus k, so with the white color one, x minus k left hand side, and with parentheses x minus k. So this will cancel. F of x equal, now distribute qx into this, qx times x minus k, x minus k, plus r times r, and that will r over x minus k times x minus k, so it will cancel again. Now look at this equation. F of x equal q of x times x minus k plus r. Now put x equal k. Once I do that, look what's going to happen. F of k equals q of k minus k. That's the beauty of this. This is 0, so this whole part will vanish. So f of k equals remainder. So remainder equals f of k. That is the proof. Now let me go back and show you see, the remainder is f of k. Okay guys, I think you understood why this theorem is true, and using this you can avoid dividing by dividing polynomial in cases where you only need to find the remainder. But when you actually need to divide, yes, you have to divide it. Okay guys, see you in next video. Thank you.